Assalamu alaikum, ma'am.
Hello, Assalamu alaikum. Are you all able to hear me?
Yes, ma'am.
How are you all?
Alhamdulillah. How are you, ma'am?
I'm good. Alhamdulillah. Acha, were you all able to understand yesterday's session? Any queries from the last class? No? Okay. I'll be sharing worksheets related to the topics we are doing in the WhatsApp group, and you can solve them at home whenever you have time at hand. And if supposing you have any questions, any queries from those worksheets, you can ask me in the next session or either on WhatsApp. Okay. Is the screen visible?
Yes, ma'am.
Yes, miss.
Okay. We're going to start off with the periodic table today, inshallah. So let's just wait for a few more minutes. So it's the people they can join and then we will. Okay. Okay. So let's begin. We're going to complete periodic table today, most likely, and In periodic table, we're going to look into the arrangement of the elements, what are groups, what are periods, and how do you identify the electronic arrangement. Then we're going to look into the group properties and group 1, group 7, transition elements, and noble gases that majorly involved. Okay. So this is what comes in from the topic of periodic table. Mostly it appears in paper 2 and paper 4. Okay. So in periodic table, you know that the model periodic table, which basically has elements which are arranged in increasing atomic number, which means that first you're going to have an element which has atomic number 1, and by atomic number I mean the proton number. So then you're going to have another element which has atomic number 2, so on and so forth. Okay, so this is increasing atomic number. So each and every element within the periodic table is basically arranged in increasing atomic number. Now, as you see all of these elements which are arranged within the periodic table, they were basically arranged and grouped together in groups having shared properties. Okay, they have similar properties. When you look into the periodic table, you are able to identify that there are vertical columns, and these columns, they are referred to as groups. So a total of how many groups do you have in the periodic table?
8 groups.
8, yes, you have 8 groups in the periodic table, and all of the group numbers, they are written as Roman numerals. So 1 till 8, or group 8 is also known as group 0, the noble gases. Then you have periods which are basically the horizontal rows, and these are 7 horizontal rows. Okay. Whenever you have to number the periods or these horizontal rows, it's better to start off at the right, so that you don't miss the first horizontal row, which has hydrogen and helium elements within the periodic table, with the atomic number 1 and 2. Next up, we have, so obviously these periods and groups, which are the horizontal rows and the vertical columns respectively, they their numbers are of some certain significance. For example, the period number basically identifies the number of electron shells. Okay, so for example, if I say that a particular element is present in period 3 of the periodic table, this tells you or determines that there are total 3 electron shells. Okay. Now, for instance, if I say it is in group 8 or group 7 of the periodic table, this means that it is present in 7th group or 7th vertical column of the periodic table. Group 7 or the group number also identifies how many electrons are present in the outermost shell. Okay. These are the number of electrons which are present in the outermost shell. So those elements which are present within the same group, they basically share similar chemical properties. Okay. So any other element which is present in group 1, like be it lithium, sodium, potassium, cesium, anything. So all of these elements which are present in a same group, they have same number of outer valence shell electrons. And valence shell, by valence shell I mean that it's the outermost electron shell. Okay, and the electrons which are present in the outermost shell, they are referred to as valence electrons. So this number of electrons which are present in the outermost shell is going to tell you the group it is present in. Okay. So this number of electrons, they can either lose, or they can is basically going to tell you what charge they are going to get whenever they get ionized. For example, metals tend to lose electrons, right? They have a greater tendency to lose electrons, as it requires less amount of energy to lose electrons rather than gaining more. So metals, they are, supposing if they're present in group 1, group 2, or group 3, they're going to lose those electrons, and as a result of which their ion which is formed is a positively charged ion, also known as or referred to as cations. Non-metals which are present on the right hand side of the periodic table, right? over here, they will be gaining electrons, and it's easier for them to gain electrons as it's only less amount of electrons that they need to gain. Okay, so they will be gaining electrons, as a result of which they get negatively charged, and they become negatively charged ions, and they are also known as anions, right? Now, whenever you look into the chemical symbols, each and every chemical element has a particular chemical symbol, and along with that, two numbers are associated with it, which is the nucleon number and the proton number. I told you this in atomic structure as well, that proton number is the smallest number, nucleon number is basically the mass number or the massive number. So the massive number out of both of these, the biggest one is going to be the mass number or the nucleon number. Both terminologies are used. Okay. So for example, if you have, for instance, if you have sodium 23 and 11, this is the smaller number. So this is going to be the proton number or the atomic number. And this is going to be the mass number or the nucleon number, which is basically protons plus neutrons. So if you want to know how many neutrons are present within the nucleus of a sodium atom, you have to subtract both of these numbers to tell you the number of neutrons which are present. And in a particular atom, protons and electrons, they are equivalent, which is why an atom is basically neutral. It does not carry a charge. So most of the groups, they have special names. For instance, group 1, they are referred to as alkali metals. Group 2, they are alkaline earth metals. Group 7, they are halogens. And group 8 or group 0, they are basically noble gases. Okay. Now, one more thing that you need to know here is that, which is usually asked in paper 4, one question definitely comes up, approximately 6 to 8 marks or 8 to 10 marks. So they ask you that regarding the state symbols of at room temperature and pressure of the different chemical elements. For example, they will ask you, they might ask you that tell us a metal which is liquid at room temperature and pressure. You should know these points. There's only one metal which is liquid at room temperature and pressure, and that is mercury. The rest of the metals, they tend to be solid, be it transition metals or any other group 1, group 2, or group 3 metals. Okay. Then you have these purple shades, these yellow shades, they are gases. Okay. Noble gases, they are referred to as monoatomic gases. Now, by now, you must know that mono means one. Atomic means they are referring to atoms, so this means only one singular atom is involved, and they do not like to intermingle. Why? Because they are unreactive. So noble gases, group 8 elements, they are all monatomic gases. They are colorless, and group 7 elements, they are diatomic molecules. Okay. All right. So which ones are diatomic molecules? Fluorine, chlorine, and nitrogen, oxygen, bromine, and hydrogen. All of these, they are diatomic molecules. All right. Then the purplish ones, they are basically liquid. One bromine. This bromine is a non-metal which is also a liquid. Iodine is tends to be solid. As you go down group 7, it is going to become it is going to change its physical state to solid. Okay. So I told you that the group number basically is going to identify the valency of that particular atom, or and how are you going to get to know the valency? For instance, if an element is present in group 1, this means it is only going to lose one electron, so the valency tends to be 1. Okay, so this is going to how you're going to correspond this with the valency. Similarly, if it is group 7 elements, they only need to gain one electron to complete their outermost shell. That is the aim of any particular element, right? To achieve a noble gas configuration. So by doing so, the valency tends to be -1. Okay, and for group 6, it is going to be -2. This means that they're going to gain 2 electrons. Negative charge comes on the ion if they are gaining, and positive charge comes on the ion if they are losing electrons. What about the metallic characteristics of the elements? By metallic characteristics, we mean to say that the metallic characteristics tends to increase as we go down the group. This means that they have greater tendency to lose electron. Okay, but when we are moving from across the period from left to right, the metallic characteristic tends to decrease across the period, right? Because we're going from metals to non-metals. So can someone tell me why going down the group, metals have greater metallic characteristics?
They're more reactive.
They are more?
Reactive.
Yeah, why are they more reactive?
They have more electrons in their out. They have like more shells.
They have more shells. So what happens if they have more shells?
They're more reactive.
Yes, you are right, but I need more elaboration to this. Yes, Ayan.
Ma'am, I think because as we go down the group, the number of shells they increase, so the number of outer electrons they also increase. And what happens is that the electrons get further away from the nucleus, so that's why the metals they have a higher tendency to lose that electron. So that's why they're really reactive.
And you said that the number of electrons in the outer shell also increases as we go down the group?
No, not down the group. The number of shells increases as we go down the group.
Yeah. The
Yeah.
number of electron shells increases as we go down the group.
Yes.
So by the number of shells when they're increasing, for instance, I say that the first element has only 2 electron shells. Okay, it's present in group period 2. Okay, in the next one, the atomic size is going to increase. Why is that so? Because the electron shells they're increasing. It is now in period 3. Period 3 means it has 3 electron shells. Then it's going to be period 4. So it means that there are going to be 4 electron shells, right? So as we're going down the group, the group number or the outer shell electron, it is still 1. This is only 1 electron. I'm talking about group 1 element, supposing. Okay. So only 1 electron is present in the outermost shell. But this 1 electron, it is actually getting further away from the positive nucleus, right? The nucleus is positively charged. These electrons, they are negatively charged, right? So as we are going down the group, the electrons, the outermost shell electron or the valence shell electron is getting further away. This means that the nuclear attraction towards the outermost shell electron, is it going to be strong or is it going to be weak?
Weak.
Weak. The nuclear attraction towards the outer shell electron is going to weaken, okay, as we go down the group because of extra shells adding up, okay, because of extra or more electron shells being added up. So here the nuclear pull or the nuclear attraction towards the outer shell electron becomes weak. Here it is very strong, okay. So this nucleus doesn't want this electron to be lost so easily, okay. This means that more energy is required for this one to lose its electron, right? However, this particular atom, which is present down below in the group, in the same group, requires very less amount of energy to lose its outer shell electron, hence making this more reactive, okay. And why do I say this is becoming more reactive? Because group 1 elements, what is their metallic characteristic? Their metallic characteristic is that they need to, or they need to lose that outer shell electron to be more reactive, so that they can obtain the noble gas configuration. So we say that as we go down the group, the nuclear pull weakens, or the nuclear attraction towards the outer shell electron or the valence shell electron weakens, as a result of which they become more and more reactive. And how do we identify or determine this? By the experiments, okay. When you carry out experiments, you're going to look into that sodium, potassium, and as you go down the group, cesium and the rest of them, rubidium, they are going to be very reactive when they react with water, okay, as compared to any other element which is present at the top of the same group 1, okay. On the other hand, if you look into group 7 elements, they have, what is their characteristic? They have a non-metallic characteristic, right? Their metallic characteristic is now going to decrease as we're going across the period. So now they're going to develop a non-metallic characteristic. And the non-metallic characteristic is that they tend to gain electron. Okay, they need to gain an electron so that they are able to achieve that stable outer shell. Okay, they need to get a full set of 8 electrons to stabilize their outermost shell. As a result of which, what is going to happen? If you look into the first one, fluorine, okay, fluorine is present in period 2 of the periodic table, right? Then as you go down, there's going to the period number increases. Fluorine is in period 3, bromine is in period 4, and again so on and so forth. So the increasing atomic size is because of the increasing number of electron shells. This means that again the nuclear pull is going to weaken at the bottom, and the nuclear pull is very strong at the top. This nucleus wants to attract the incoming electron towards itself with its strong nuclear pull. Okay, but down below, because of added electron shells, the nucleus.
मुझे क्या पता क्या पढ़ा रही, मैं सारा पढ़ लिया हूँ.
Who's this? Switch off your mics, please. अगर आपने पढ़ लिया है तो फिर आप जो है वो किसी और क्लास में एंटर हो जाइएगा. जो पढ़ रहे हैं उनको पढ़ने दें. So I was saying, as we're going down the group, in group 7, they have a characteristic, they have a non-metallic characteristic whereby they're going to gain electrons, and because the nuclear pull is going to weaken as we go down the group, so they're going to have a greater tendency to gain electron at the top and very weak tendency to gain electron at the bottommost. So what do you think? Which one is going to be more reactive in group 7, halogens group? The top one or the bottom elements? Yes, Zoya.
The top elements.
The top elements. They are going to be the most reactive. This means that fluorine is going to have very strong reaction with water or any other element, and that is because of the greater tendency to attract the electrons towards themselves. Okay. Any questions by far? Yes, Zoya.
Miss, as we go down, does the non-metallic character increase?
As we go down, you're asking the non-metallic characteristic?
Yeah, it increases, right?
The non-metallic characteristic is going to increase, yes.
Okay, thank you.
All right, now we're going to discuss and take a look at the properties of the metals and the non-metals. Metals, they have approximately 1 to 3 electrons in their outermost shell, and non-metals, they tend to have 4 to 7 electrons in their outermost shell. Metals, they have metallic bonding, which means, which is basically present because of the positively charged cations and a sea of delocalized electrons, okay? So this metallic bonding, which is basically present, is because of the positively charged cations and the sea of delocalized electrons. Okay. This creates an electrostatic forces of attraction between the positively charged cations and the negatively charged electrons, and this is referred to as the metallic bonding. Okay. This is going to be your metallic bonding. Now, for instance, if I say now group 1, group 2, and group 3, all of them, they are metals, right? But how do I know, how do we determine that which metal is going to have greater or characteristic of metals? Or how do we determine that where in which element, in which group elements they will have strong metallic bonding? Group 1, group 2, or group 3 has strong metallic bonding. How do we determine the strength of metallic bonding in all of these three groups? Yes, Zoya.
I think group 1 because they can easily lose their electrons. They only have to lose one electron. So their metallic bonding is more.
So this basically tells you the reactivity. Okay, the easier a particular element is going to lose or gain electron, this is going to determine its reactivity. All right. But for instance, if I want to know the strength of metallic bonding in any particular metal, then I'm going to look into the greater the electrostatic forces of attraction are present in between the positively charged cation and the sea of delocalized electrons. Okay. Now, the greater the electrostatic forces of attraction are basically developed, the greater will be the strength of metallic bonds, right? So in group 3, the group 3 metals, they tend to lose all of their 3 outer shell electrons, right? So when they're going to lose all of their 3 outer shell electrons, this means that they have greater sea of delocalized electrons as compared to group 1 metals, which are only losing their 1 electron. Okay. So the greater the sea of delocalized electrons, the greater will be the electrostatic force of attraction between the positively charged cation and the sea of electrons, which is why the metallic bond strength is much greater in group 3 metals as compared to group 1. But when we say about the reactivity, when we talk about the reactivity, it is the most reactive elements are present on the bottom left of the periodic table and top right of the periodic table. Okay, group 7, top right and bottom left in group 1. Okay, yes, Ryan, you were saying something.
No, Miss, I just wanted to ask how you know how strong the electrostatic forces of attraction are, but you already answered that.
Okay, is this clear?
Yes, Miss.
Okay, moving on. Non-metals, they tend to form covalent bonds by sharing their outer shell electrons with the other atoms. While we discuss the electrical conductivity and the oxides and how do they react, the metals, they tend to be good conductors of electricity and heat. Whereas non-metals, they are poor conductors of electricity and heat. They are good as insulators. And metals, they form basic oxides. Now we will do this part in particularly in the acid, bases, and salts when we do types of oxide. Just to clarify, basic oxides are those oxides which behave as bases. Okay, how do they behave as bases? They basically react with acids to form salt and water. Whereas non-metals, they tend to be acidic oxides. They behave as acids. They react with bases to form salt and water. Metals, they react with acids, whereas non-metals do not react with acids. Okay. Some of the metals which are very less reactive or naive metals, they do not solely react with acids. For example, copper, silver, or gold, platinum, these are very naive metals. So they're not going to react with acids until and unless you have compounds of them. All right. Moving on to physical properties, metals, they tend to be malleable. They are ductile. They can be shaped. They can be bent. They have high melting and boiling points as compared to non-metals. Non-metals, they are flaky, they're brittle, and they have low melting and boiling points. Okay. So these are all metals, and metals, they tend to be basic oxides. Non-metals, they tend to be acidic oxides. Okay. This we have discussed already. There's one more thing, electronic configuration. For example, if I say that sodium has an atomic number of 11, this means that these are the same number of electrons, right, which are present in sodium atom. So what will be the electronic configuration? The first shell has a maximum capacity to hold up to 2 electrons. The second shell has a maximum capacity to hold up to 8 electrons. And the next shell has a maximum capacity to hold up to 8 electrons. But when you're going to look into AS chemistry, you will get to know that the third shell can actually occupy a maximum of 18, and the fourth shell can actually occupy a maximum of 32. All right. But for now, at this point in time, you should consider this electronic configuration. So, for example, if you have 11 electrons, the electronic configuration is going to look like 2, 8, and then 1. 2 plus 8 is 10. 10 plus 1 is going to be 11. So this last number basically tells you the group number of the periodic table. This means that this particular element with atomic number 11 is present in group 1 of the periodic table. And there are total of 3 electron shells, 1, 2, and 3. Okay. So there are, the period number is going to be 3. Are we clear?
Yes, miss.
Okay.
Yes.
Let's move further. Okay, now there are some general patterns, trends, and by which we predict properties of the elements which are present in same groups or across the period. So by looking into their common properties, we say that this is the general trend in the same group. For example, group 1 elements, they react very quickly with water. They tend to be very, very reactive. Okay, extremes of any on both the sides of the periodic table, they are very reactive. Noble gases, they are not at all reactive. Okay, excluding the noble gases in the first part. And noble gases, they tend to be they tend to be monatomic gases. Transition elements, they're always denser than group 1 elements or group 2. And reactivity decreases as we go down group 7, and reactivity increases as we go down group 1. Melting point decreases as we go down group 1. Now, we identify these trends by looking into the chemical experiment. For example, if you see that lithium reacts with water, lithium, or I told you all metals, they are usually solids other than any exceptions. So lithium reacts with water. Pure water is completely liquid. Anything pure liquid is going to be liquid as a state symbol. But if any liquid is added to water, then the state symbol is going to change to aqueous. So lithium hydroxide, which is produced as a result, this is now diluted with water. Okay, so the aqueous lithium hydroxide will be written as AQ as a state symbol, and hydrogen gas is involved. So the general reaction of metals reacting with water is that whenever metals, they react with water, they produce their own hydroxide, and hydrogen gas is evolved. Okay. Now, as you go down the group, hypothetically, you would suggest, or you would think that the metals reactivity is basically increasing, right? They're getting more and more reactive, which means that the hydrogen gas bubbles which will be produced, they will be produced very quickly, or more bubbles of hydrogen gas will be evolved or will be observed. Okay, and the rate of reaction is going to double, or maybe it is going to simply increase. Okay, this means that the same products are produced, or they are achieved, or they're obtained within less amount of time, right? Is this point clear so far? This is how you can correlate your chemical reactions and your different concepts of rate of reaction and everything else. Why am I telling you this? Because in paper 6, you are asked to correlate all of these concepts. All right. So any equation will be asked to you. Maybe it is a sub part of it. okay, of the main question. So you should know everything else. Reaction for lithium is very slow. Why? Because we said that in group 1, the reactivity at the top is less, and as you go down, the reactivity increases. So the bubbles of hydrogen gas, they are evolved. This is your observation. You must know this is your observation. Hydrogen is a gas, so obviously bubbles of hydrogen gas will be seen or observed. Lithium's melting point is higher, but also whenever metals react with water, this is an exothermic reaction. This means heat energy is produced. Okay. So since lithium has greater melting point, it does not melt. But as we go down the group, the melting point decreases, okay, which is why the production of heat, as it is an exothermic reaction, this production of heat is going to melt the sodium and the potassium metals both. Okay, the reaction gets more and more violent. It gets more and more explosive. They melt into a shiny ball, and they also float around the surface. Okay, this tells you that if they are floating onto the surface of water, this means that they're actually less dense. Okay, they melt because sodium it has low melting point, and a lot of heat is produced in this reaction. Hydrogen is also evolved, and white trail of sodium hydroxide is produced. Now, one thing more. Usually, metal group 1 and 2 metals, their oxides, they tend to be white in color. But if they are dissolved in water, the hydroxide which is produced as a result will be colorless. Okay, let me repeat myself. I said that metal oxide, group 1 and group 2, they tend to be white in color. They're white oxides, solid white oxides. But if they're dissolved in water, they form their own hydroxide, their own metal hydroxide, which is going to be colorless. Okay. So sodium hydroxide is highly alkaline. Its pH is going to be approximately 14. And as you go down the group, like potassium or any other element, the reactivity is again going to increase. More and more hydrogen gas bubbles will be seen or observed. And potassium also burns with lilac colored flame because of its greater production of heat. That greater production of heat basically tends to produce this lilac colored flame, which is distinctive of only potassium metal. Is this point clear so far?
Yes, miss.
Okay. Next, we look into the rest of the metals. As we go down the group, rubidium, we see that it explodes with a sparks. Rubidium hydroxide is produced with. These are all the predictions, okay? Because the rest of the metals, we can perform their experiments in school labs or anything else. But since they are so reactive, so we only are able to predict these chemical reactions for the rest of the group 1 metals. So we say that their reaction is going to be violently explosive, lots and lots of heat energy will be produced, and their own hydroxide will be produced. Okay, so solution of their own metal hydroxide is produced as a result. Moving on. Group 1 metals, we've already discussed. We said that group 1 metals, they have a special name, and that is alkali metals. They form, why they're alkali metals? Because they are basic, they form basic oxides, and these basic oxides, when they dissolve in water, they form alkaline solutions of their own metal hydroxides, and they have higher pH values as well. They only have one electron in the outermost shell, which makes them so reactive, and this reactivity increases as we go down the group. They're very soft. They're also denser as you move down the group, but only sodium and potassium does not follow the density trend. Okay, the mass increases, the density also increases, but sodium and potassium, they do not follow they deviate from this trend. Okay, they do conduct electricity and heat. They have shiny silvery surfaces, but since they are so reactive, when you're going to freshly cut a piece of soft group 1 metal, as soon as you cut it, you will be able to view in the cross section. You will be able to view the shiny silvery surface of the metal, but it is so reactive that it is going to react with the atmospheric oxygen, as a result of which it is going to form a layer of its own oxide. So that shiny silvery surface it's going to become dull with the passage of time. Okay. They all have low melting points, low densities as compared to any other metals, especially the transition metals. The transition metals, they have higher melting points, and also they have very high densities. Okay, these comparisons, they are asked. they are stored under oil, and that is because of their reactivity with they're readily reactive with oxygen and also water, which is present in the as moisture in the atmosphere. Okay. Moving on, these are your past paper questions. I'll share this PDF as well in the group. Okay. And I'll share more worksheets regarding this topic and redox. So in the next session, if you are able to review these worksheets, and if you think you have any questions, any queries, you can ask me. Okay. Halogens, they're group 7 nonmetals, they're poisonous, and they are basically diatomic molecules. This di means 2, okay? Mono means 1. So diatomic, by diatomic, it means that 2 atoms, they of the same type, of that same similar 2 atoms, they are going to combine together covalently, and they're going to form one particular molecule. So all halogens, they are diatomic molecules, they are colored, and they have distinctive colors. Now, for example, fluorine and chlorine, they tend to be gas. Okay, their physical property is that this color is going to change. This color darkens as you go down the group, and along with their physical state. The fluorine and chlorine is a pale or pale yellowish green gas. Bromine is a red brown liquid. Okay, and iodine is a gray black solid. So, what would you predict about acetylene? Acetylene, which is after iodine or below iodine in the same group, what do you think? Yes, Zoya.
It will be a black solid.
Yes, it is going to be a black solid. So it's more darker, much more darker than iodine. If I say iodine is a gray black solid, so acetylene would be black, and again, it is going to be solid. So the density basically increases. Why do I say that the density increases? This is asked in multiple times in the past papers, that the reason for the density increasing is because of this change of state, right? When you have solids, you know that from your first topic, solids, they have greater density, gases, they have less density. Okay, so because of this change of state, the density is also going to change. The change of state also means that the boiling point also increases. Why? Because the intermolecular forces of attraction, they are getting strong. The greater the intermolecular forces of attraction are going to be, the stronger the intermolecular forces of attraction are, the boiling point is also going to increase as we go down the group. Okay. Then we've discussed this. Why do the reactivity decreases as we go down group 7? Moving on, this is important. You must know this. This is the halogen displacement reaction. Halogen displacement reaction is that a particular halogen displaces the other halogen from its aqueous solution only if it is more reactive than that. I'm repeating myself. The more reactive the halogen is going to be, it will displace the less reactive halogen from its aqueous solution. Okay. For example, if you have an aqueous solution which has chloride ions. Now, chloride ions, they can obviously not react with chlorine. But when you add bromine, bromine is less reactive, right? So bromine cannot displace chloride. However, if bromide ions, they are present, it will be displaced by more reactive chlorine. Okay. When they displace this, so a particular chemical reaction takes place, and because of which the color change is observed. Okay. So for example, if I say you have potassium bromide is aqueous in its nature, right? It reacts with chlorine, aqueous chlorine, and then it forms potassium chloride. This means that, or supposedly if you add chlorine gas to it, so this chlorine is going to displace bromide ions, as a result of which it will form potassium chloride, and this bromine aqueous solution will form. Bromine in its liquid state is orange brown. You can also say it is brownish liquid. But after it gets more and more diluted, it turns its color into yellow. Iodine as a solid, it is at room temperature and pressure, it is gray black solid. in its aqueous solution, it is brown, and iodine in its gaseous state is purple. They are gaseous. In gaseous state, iodine is purplish vapors. Okay. Either remember these, or if you can jot down these somewhere, you can do that as well. Okay. You must know all of these colors that I'm talking about. Okay. So chlorine is very pale green, or you can say it is pale yellowish green, but when it is diluted, it appears to be colorless. So some agents, they are added to these solutions to get to know the actual color of these displaced elemental forms of the halogens, such as bromine, iodine, or chlorine. Okay. Moving on. Is this point clear so far? How we are going to determine which halogen is going to displace the other one? These are important. The observations you must know. Any questions by far? That's why we keep alkali metals in oil. Yes, yes, Ayan. Alkali metals, they are kept under or stored under oil because of greater reactivity with the air. In air, you have water molecules, you have as moisture, and you also have atmospheric oxygen. So both of these, they can simply react with these alkali metals or any other metal. It can be iron even.
Okay, miss. Thanks.
Okay. So chlorine cannot react with potassium chloride, but no reaction is also seen with bromine and iodine, because bromine and iodine, both of them, they're less reactive than chloride. Bromide can be displaced by chlorine, but it cannot be displaced by iodine. Why? Because bromide is more reactive than iodine. And when chlorine displaces the bromide ions, the bromine is produced, and this bromine is seen as or observed as yellow-orange color. Potassium iodide is displaced by chlorine, and brown color of iodine is observed in its aqueous solution. Okay. But iodine in its vapor form, it is basically purple in color. Remember this. So let's end the session till here for now. I will send you 2 worksheets regarding these. And tomorrow, inshallah, we will cover transition elements and the noble gases. This is left. And then we're going to, inshallah, move on to metals. All right. Any questions by far? Please mark your attendance before leaving. Yes, Zoya.
Miss, as we go from left to right in the periodic table, the atomic size decreases, right?
The outermost,
No, the atomic size of the element decreases.
yeah, the atomic size decreases. Yes.
Yeah, but I didn't understand why.
Why? The atomic size basically decreases because of the greater pull of the nucleus. Okay. The atomic number basically increases when you go from left to right of the periodic table, right? So when you're going from left to right by increasing atomic number, it means that the proton numbers, they're increasing. And when the proton numbers, they are increasing, this means that more positive charge is present within the nucleus. When greater positive charge is present within the nucleus, it is going to attract the outermost shell electrons greatly, okay? Which is why the atomic size tends to decrease. It has greater pull onto the outer shell electrons because of increasing positive charge, or you can say increasing proton number across the period from left to right, which is why the atomic size basically decreases.
Okay.
All right. Take care. Lafis. Thank you. Bye-bye.
Lafis.
Lafis.
Man, just one thing that should we know the like the presence of positive ions or negative ions, like how to determine the positive or negative ions? Do we need to know in paper 4 or paper 2? Because in paper 6 it is given in the back of the paper, right?
For instance, tell me some, can you
Like,
elaborate on it?
Yeah, like the presence of cations or anions, like the reactivity of nitrate when it is added to some sodium hydroxide.
Identification of ions and gases you're
Yes, yes,
talking about.
yes. Identification. Yes, yes.
It is given. It is given at the
So, ma'am,
end of
for
it.
can those questions come in paper 2 or paper 4? Or
Yes,
no?
they can. They
So,
can.
ma'am, we need to remember it.
Yes, better off to memorize it. Better off to memorize it. In paper 6, it is given. So
Yes.
you can refer to it in paper 6. But if supposingly if any question comes in paper 4, then it's better that you memorize it at least. At least the most common ones you should know.
Okay. Ma'am, when we are going to start the past paper session, inshallah? Like at mid-March?
Mid of March, most likely. After as soon as I'm done with these compensatory lessons, I've planned these on the schedules that I told you on the
Okay.
days. But as soon as we're done with that, inshallah, we move on to past papers. Don't worry.
Okay. Okay. Ma'am, you're going to share this, right? This recording here.
Yes. I will. I have. I think uploaded yesterday's as
Yes,
well.
yes, you did. Yes.
All right.
Yeah. Okay, ma'am, and sorry for hearing that disrespect. I wasn't expecting this. I will inshallah, like you can report it to anyone.
I plan to. Thank you.
Okay. Allah Hafiz,
All right.
ma'am. Thank you
Take
so
care.
much.
Bye.